So the data set we are going to use here is the consumption data set. So let's import our data set. So to import our data set, we all know, we go to open, then we click data, then we select the option data. Now remember, our data set is an Excel file. So the format, or rather the file type, has to be Excel. So now you navigate to where you have stored your data. If you don't have the data, you can text me on WhatsApp. So we open our data set, and of course our first is actually the variable name. The first row is the variable name. So you click OK, and there we go. Our data set is loaded. Now this data set is actually an actual data set that represents the consumption. We have consumption. We actually want to see if there is a relationship between the consumption and the income one earns, as well as the size of the family, the interest rate, and the net wealth of this particular individual. So, could there be a relationship, or rather association, between consumption and income? So, that is what we are trying to investigate from this data set. And that is what we call inferential analysis. We are trying to make conclusions for the entire population based on this sample data set that we have. Because at the end of the day, after the investigation, or rather the analysis, we'll be able to tell if there is association between consumption and income. Or we can even predict the consumption given the income. So inferential analysis is not only predicting the presence of relationship, but rather also predicting given the relationship. So that's what we want to discuss in these remaining sessions. Now today we will start with correlation analysis. And we discussed correlation analysis actually when we are doing advanced Excel. Now, basically, correlation analysis is used to measure the strength of linear relationship, or rather association, between two continuous variables. Like, we want to see if there is a linear relationship between consumption and income. What do I mean when I say linear relationship or association? I mean, what do we investigate? What happens to consumption when income increases? Does the consumption increases as income increases, or it decreases as income increases? What is actually the association? What is actually the relationship between the two? As well, what happens to consumption when the size of the family increases? Maybe you have 2 kids now, and in the near future now you are blessed with two more, that is now 4. So what happens to the consumption? Will the consumption increase or decrease? What about the net wealth? When the wealth now increases? So we want to investigate that. And to investigate such linear relationship, we use what we call the correlation analysis. Now, the first step before we actually do the correlation analysis is actually to investigate and see if there is actually, or there could be, a linear relationship. We first investigate the presence of a linear relationship between the variables. And the best way to investigate here is actually to use a graph. So normally we use a scatter plot. Remember when we were doing advanced Excel, we were saying a scatter plot is just basically showing how the points are related, the distribution of the points in the data set. So we will do a scatter plot, let's say for consumption and income, and observe if there is any possibility of linear relationship between the two variables. So let's do the graph. To do the scatter plot, we go to graphs, then we go to legacy dialogues, and we select scatter stroke dot. We select scatter here. Now there are multiple choices of scatter or dot that you can use. You can use the simple scatter, the matrix scatter, but because we just want to observe the linear relationship, I'll use the scatter in this case. So define that. So let's define the scatter plot, and selecting define will open the simple scatter plot dialog window. So here we put our y variable, that here is the dependent variable consumption, and maybe we want to investigate this with income x. So you can add the titles if you want. Using this title, you can say scatter. You can say scatter. Okay, you can say scatter plot for consumption, and it's up to you. You can even do it without consumption and income. Consumption and income. That's enough. And I click OK. And I click OK. And I click OK. When we observe the graph of consumption and income, the essence of scatter plot actually investigating a linear relationship is to see if you can fit a line of best fit. You realize from this scatter plot, we can actually fit our line of best fit, which is moving in that direction. My cursor is moving. This could be our line of best fit there. So actually, there is a possibility of a linear relationship between consumption and income. And if I fit a line of best fit here, realize the line of best fit will indicate that as income increases, the consumption also increases. Because here is our line. Our line is imaginary for this case. So this is our line here. So as income increases, we are expecting the consumption to also increase. So at least we have a clue, we have a hint. We are seeing the possibility of having a relationship, and actually a positive relationship. Whereas income increases, also consumption is increasing. But we want to see what is the actual value of the increment. On what value if this income increases, consumption increases, and all that. What is the strength of that association? So now to get the real value of the association, we now do the actual correlation analysis. So to do the correlation analysis, we go to analyze, then we go to correlation, and we select bivariate. Guys, if I'm very fast, you tell me that you are very fast. Then you go to bivariate correlations. So you select your variables. I want to have consumption and income. Now the push buttons here, you can see there is options. Now the options, basically you can add the statistics such as the mean and the standard deviation. But I know we would have done the descriptive analysis, so there's no need to add that. Now down here we have the correlation coefficients. I know, don't be scared about the name. The names. We have the Pearson product correlation coefficient. This is the mostly and commonly used type of correlation coefficient, and the reason being the correlation analysis is based on assumptions. There are certain underlying assumptions that we normally consider when doing the correlation. One of these assumptions is that the association or the relationship is linear. I hope you have seen all along of me saying a linear relationship, possibility of a linear relationship, a linear association. That is one assumption. Another assumption is that, which we actually discuss that on its own, is that our data set is normal distributed. our data set is normal distributed. We'll talk more about normal distribution and all that. Now, if some of these underlying assumptions do not hold, is when now we go for the other types of correlation, such as correlation coefficients, such as the Kendall curve. This one is normally used when the data set does not follow a normal distribution. I know in this class I can see there are some statisticians here. We say it is used when the data is non-parametric. When the data is not normal distributed, we say it's non-parametric. So Kendall curve is a perfect example of a non-parametric method. Never bother about that, because in most of the cases, the assumption will always hold, or will transform the data so that the assumption holds. Now, the second thing is the test significance. Okay, the test significance is crucial in this case, because it's either we have a relationship or we do not have. So the relationship could be on the negative side or the negative side, but it is there, so it's crucial. Now there is this check button here for flag significant correlations. I normally check this. I have it ticked or checked because it actually gives us a star to those correlation coefficients, the correlation values that are significant. So it is a perfect way of not even considering the significant level, but we just look at the correlation coefficient. If it has a star, means it is statistical significant. So then I'll click OK. And I'll have my correlation matrix. You can see this is my correlation here. The same we are getting in advanced Excel, and I'm expecting you to be able to interpret this, and my friend Morrison will be able to tell and all that. Now, we were saying when we were doing advanced Excel that normally, this is general before we come to normally the correlation value will range between 1 and -1. The correlation value will always be between -1 and 1. Now imagine you draw a number line. I know all of us know number line. We are from high school, that is Form 1 mathematics. Now that number line, at the extreme left, we have -1, and at the extreme end right, we have +1. So -1 and 1. Between -1 and 1, of course, we have a 0. Now, between -1 and a 0, we have -0.5. And between -0 and 1, we have 0.5. So those are the points that where our interpretation will be different depending where the correlation value lies. So let's start with -1. When we have a -1, we say we have a perfect negative correlation between the variables. The two variables have a perfect negative correlation. Now, when we have, that means that if one variable increases, the other one also perfectly increases, and like that. Now, what if we have 1? When we have 1, we say there is a perfect positive correlation between the variables. It's perfect positive correlation between the variables. What about when we have 0? Now, when we have 0, means there is no correlation between the variables. That is, there is no association between the two or more variables. It could be more. But we are taking a case of 2. Let's now go back to between -1 and -0.5. Now, between -1 and -0.5, we say there is a strong negative correlation. there is a strong negative correlation. That is now between -1 and -0.5. Now, between -0.5, between -0.5 and 0, we say there is weak negative correlation. There is weak negative correlation. Now let's go to the right. Between 0 and 0.5, we say there is weak positive correlation. There is weak positive correlation. And between, there is now 0.5 and 1, we say there is strong positive correlation. But basically, that is it. That is it. Now, realize the correlation is there. But the question is this correlation significant? Remember we agreed last time that whenever we say significant, it don't mean importance in statistics. Like, is it negligible or not? That is what I'm trying to say. So you realize to check if the correlation value is significant, or rather statistical significant if you want, we will consider the significant value of the correlation. Now, if the significant value is less than 0.05, then we conclude that the correlation is significant. The correlation is significant. That was general. Now let's go to our interpretation. Now you realize in this correlation matrix, the diagonals are 1, 1, because it is like the diagonal is a correlation of the variable itself. You can see this is consumption to consumption. That is why it is 1, 1. But now, the correlation between the two variables we are actually observing is the intersection of the row and the column. That is the intersection of income and consumption. And the correlation here is 0.815. The correlation here is 0.815. This implies that consumption and income have a strong positive correlation. They have a strong positive association. This means that as income increases, we are expecting the consumption to also increase. But when we look at the significance value, it is actually less than 0.001. Remember last time we were saying that we don't say that the significance is 0.000. No. We say that the significance is less than 0.001. Because actually this is not 0.001. We said when we double tap this value here, we realize it has some value as it proceeds. So we'll say that because the significant value here is less than 0.001, which again is less than 0.005, then the correlation between income and consumption is significant. Or rather, we'll say there is a significant correlation, or rather association, between consumption and income. So by just looking at this table, this is the statement I say, from the correlation analysis of consumption and income, the correlation value is 0.815. This implies that there is a strong positive association between consumption and income, such that as income increases, the consumption also increases. The significant value of the correlation is less than 0.001, which is less than 5% significant level, and therefore the association between consumption and income is statistical significant. It is statistical significant. And that is now one of the threshold analysis, correlation analysis. Remember now we are concluding to the entire population where this sample data was obtained. I don't know if that is clear. Guys, am I making sense to someone? You mean I come up again from A to Z? Like I start off with...
No.
Okay, this...
we are
saying that we are looking at the correlation value and the significance. Now the correlation value is greater than 0.05. Actually it's close to 1, 0.8. So it's a strong positive correlation between income and consumption. That is one. Now again, the significance, okay, let's just say it is 0.00. So this means that it is less than 0.05, and therefore this association is statistical significant. So saying the correlation from the correlation analysis, the correlation value of income and consumption is 0.815. This implies that there is a strong positive correlation between income and consumption. The significance value of the correlation coefficient is actually less than 0.001, which is less than 5% significant level, and therefore the association of consumption and income is statistical significant. I hope that is clear.
It's clear.
Now, that is good. I want us to look another case here, because this is a positive. Mind you, this is an economic data. Looking at it, I'm expecting as maybe the family increases, the consumption, okay, could be increasing as well. So I'm just trying to look at a negative aspect. I think I've modified this data set to give that desired output. So let's look at the correlation of consumption and the size of the family. Remember, we go the first step, that is generating the graph to see if there's a possibility of a linear relationship. And it's a simple scatter plot for this case. So I define the scatter plot. Now my x-axis still I'll have the consumption, but on my y-axis I'll remove the consumption and have the family size. Now I click OK, and I'll give time for the graph to be generated. Now look at this graph. It is quite different from what we were having previously. I hope you can see how the pointer is different. Now from this graph, if I try to come up with a line of best fit, you realize my line of best fit will actually be moving downwards this way. I hope you are seeing how my cursor is moving. I mean, I'm expecting my line of best fit to be moving this way, like that. Which means that, whatever that implies, there is a possibility of a linear relationship. But that linear relationship is actually negative, because if the line is coming downwards, like that, means that as the family size increases, the consumption increases. That is what is being suggested. If I have my line of best fit here, it is suggesting a linear relationship, because I can have my line of best fit, but it is actually suggesting a negative relationship. So, does this negative relationship really exist, or we are just imagining that? But the graph is suggesting that. So let's confirm that now using the correlation analysis, using the correlation analysis. So to run the correlation analysis, I'll go to analyze, I'll go to analyze, I'll go to analyze, then I go to correlation. Of course, it's bivariate correlation. Now I have consumption, but I don't need income. I need family size, and I know family size here. Okay, the rest of the things will remain just as they are. Remember that we have discussed like that. So I'll click OK. I'll click OK. And interestingly, actually the correlation coefficient is negative. So actually the correlation matrix confirms that there is actually a linear negative relationship between consumption and family size. So when I interpret this, you realize that I'll say from the correlation matrix, the correlation coefficient, the Pearson correlation coefficient of consumption and family size is negative 0.835, implying that there is a strong negative association or other relationship between consumption and family size, such that as the family size increases, the consumption increases. The significance of the correlation coefficient, the significance of the Pearson correlation coefficient is 0.000, let me just say that, which is less than 5% significant level, and thus the association of consumption and family size is significant. Now there is now correlation. Now you see there is a positive case and a negative. Now there is now a correlation analysis or other correlation analysis of two variables. But what about, suppose now I'm interested to see or rather to investigate the correlation of actually consumption and all other variables that are go. Not to do consumption and income, then come back to do consumption and family, then come back to do the interest. I can just decide to do with all of them. And actually, that will not affect the correlation of consumption and income, or rather the consumption and the family size. If I do all of them, it doesn't. So actually, that is the best way if you want to investigate the correlation of consumption and income, as well as consumption and family and the other variables. It is good to do it once and have the correlation matrix and focus on the interpretation. So let's just do that. We'll go to analyze, correlation, still under bivariate. Now because it's consumption against all other variables, I'll highlight all of them except the observation date, because that was just the date when we collecting the observations. So moving all the variables there, of course the rest of the things remain as they are. I'll just click OK. So now here I have a correlation matrix of all the variables, and the variable of interest is income. You can see on the diagonal I have 1, 1, 1. Now you realize one thing, these values here are just repeated down here. So just need to focus on one end. And actually for me, because I want to investigate the correlation of consumption and all other variables, I'll just use this first row and the columns, because the correlation of consumption and family size is here, correlation of consumption and income is here, and these two are getting them separately up here, and the correlation of consumption and interest rate is here, correlation of consumption and net worth is here. The significance as well is here, is given down here. and the number of observations here. Now you realize when actually it is significant, that is why I was telling you it is good to check flag the significant value. You can see they are all having a star whenever they are actually significant. So very fast, in less than 5 minutes, I want to get how many are this? We have four variables. I mean, one to interpret the correlation of consumption and family size, consumption and income, another one consumption and income, another one consumption and interest, and the last one consumption and net worth. Very fast, in less than 5 minutes. Volunteers. So you just raise up your hand and I will pick you. Volunteers. Yes, Evelyn.
Okay, let me try. Okay. From the correlation analysis between consumption and family size, the correlation coefficient is a negative 0.835, which shows that there is a strong negative correlation between consumption and family size. The significance level is also 0.001, which is below 0.05, which indicates that the findings are statistically significant.
Perfect. Awesome. But I thank you. That was really good. Any other person? I know you can continue with all of them, but let's move on to other members. Yes, Mr. Morrison.
Okay. I can give it a try.
Yes, please.
Now, the correlation between consumption and income is a positive 0.815. So it's a strong positive correlation. And the significance level of 0.01 is greater than the significance level of 0.000. So the correlation between consumption and income is statistically significant.
That is awesome, Mr. Morrison. That is awesome. It's very correct. I know some were worried about the significant level, but okay, Evelyn was correct. I was correct. Morrison is correct. Morrison is using a significant level of 1%. That is 0.01. Still okay? Still okay because even our table is giving us 0.001 down. So it's still okay. Depends with the significant level you are given. So that is awesome. That was a correlation analysis of two variables and even more variables. I mean, we were looking at rather investigating the possibility of association or rather relationship with even two variables. Now, there is a case where we have what we call partial correlation. Look at this. When we were navigating to do the correlation, we realized we were having an option known as correlate then partial, which means we'll be doing what we call partial correlation. Now the question is, what is this partial correlation? What is the best scenario of partial correlation? Now partial correlation measures the strength of relationship between two or more variables while controlling the effect of one or more other variables. Hope I'm not confusing anyone. I'm saying partial correlation measures the strength of the relationship between two variables while controlling the effect of one or more other variables. I know the definition could not make sense, but let me give this example. Suppose, or at times, you may want to see if there is a correlation between the amount of food you eat and the blood pressure. Maybe I've just taken a heavy meal and I want to see if that particular meal has a correlation or rather an association with the blood pressure. After taking this heavy meal, will the blood pressure be increase or remain constant? So I want to investigate that. Now you realize such instance I need not maybe to avoid some other circumstances, let's say exercise. Maybe after taking that heavy meal, I just rest and not to do exercise. Because doing exercise maybe could affect the blood pressure. Such that now when I do my correlation analysis between the food I eat and the blood pressure, it results to a significant association, but actually that association arises because of the fact that after taking the meal, I did some exercise. So what I'm trying to say is that we are doing a correlation between the food I've just eaten and the blood pressure, but controlling the exercise, the amount of exercise. Like I'm controlling that so that I'm only getting the effect of these two variables. I don't know if you're getting that. So you might want to see if there's a correlation between the amount of food eaten and the blood pressure, while controlling for the weight or rather the amount of exercise. That is what now we call partial correlation. That is what we call partial correlation. So generally, partial correlation measures the relationship between two variables, say the variable x and y, while eliminating the influence of a third variable, say a variable z. So if this variable z had an effect on the two variables that we want to investigate their correlation or other association, we are eliminating that effect. That is what I'm saying. I've taken a meal and I want to investigate the effect of the meal on the blood pressure, the relationship. So any influence as a result of amount of exercise, I'm trying to eliminate that. There is now partial correlation. I don't know if guys you understand what I'm saying about partial correlation. Is it making sense? Are you understanding the scenario here of partial correlation? Now, this is a case, let me use this case of this data set. Suppose we want to investigate the correlation of consumption and income, eliminating the effect of the family size. From these two. Or, okay, maybe family size is not making sense as such, but let's say we want to investigate the correlation of consumption and income, eliminating the effect of network. Because could be the network is affecting the consumption as well, or the network could be affecting the income. So the relationship between the consumption and income could be as a result of actually because it is the network that is actually affecting the income, which again affects the consumption. So we want to remove the effect of this on this, which can be resulted to affecting the consumption. That is the partial correlation. I believe you understand that. Now to do the partial correlation is very simple. We go to analyze, then we do correlation, and this turns out not Bivariate but partial correlation. So we want to investigate the correlation of consumption and the income, excluding the effect of network, maybe from the income or consumption, excluding the influence of network. Now other options still we have the same, the means and those are the descriptive statistics. We talk about missing values and excluding missing cases when we're doing the descriptive, so you don't have to mention that. We just click continue and we say okay. Now That is our correlation matrix or result. Now you realize the result is not any different. I mean, the way it looks like is just the same. The general output, that is not the values and anything, is just the same as when we run the correlation between consumption and income. Only that I can tell that this one is a partial correlation because I have another third variable here at the far left, at the far top left here, network. Meaning, network here is actually a control, a control variable. It is a control variable. Now, I want us to interpret this, the partial correlation. But before we interpret the partial correlation, let's do the bivariate correlation of income and consumption so that you can have the output down here. And I know why. So we'll go back and do correlation, now bivariate, and we say we only want the consumption and income alone. And we click OK. So you see you have the two results. You can note the difference. Now we just have consumption, income, no type of variable here, meaning this is not partial, but the other one is partial. So basically, from this partial correlation, we will say that, well, of course we start by looking at, the correlation, the Pearson correlation coefficient value, which is 0.668. So it is positive and it is strong positive. But now, when you are interpreting this, you need to include all these three variables in the statement: the consumption, the income, and the net worth. You need to include the three. I mean, this is how we interpret this. It's saying, from the correlation matrix, from the partial correlation matrix, the correlation value is, or the Pearson correlation coefficient is 0.668. This implies that there is a strong positive correlation between consumption and income, whilst controlling for net worth. I'll repeat that. From the correlation coefficient matrix, the correlation value is, the Pearson correlation coefficient is 0.668. This implies that there is a positive or a strong positive correlation between consumption and income, whilst controlling for net worth. The significance of the Pearson correlation coefficient is less than 0.001, which is less than 0.05 significant level, and therefore significant. And therefore, the correlation of between consumption and income, while it's holding for net worth, is significant, while it's controlling for net worth is significant. I don't know if you're getting the interpretation. Partial correlation. I'll repeat for the last time. One last time. From the correlation matrix, the Pearson correlation coefficient is 0.668, which implies that there is a strong positive correlation between consumption and income, whilst controlling for net worth. The significance is 0.00, which is less than 5% significant level, implying that the correlation or association of consumption and income, while it's controlling for network is significant. Kindly confirm.
Yes. Yeah.
Oh yes, yeah. That is okay. That is okay. Now the question is, here there is one interesting question, and the question is network having an influence in controlling the relationship between consumption and income? Is network having an influence in controlling the relationship between network, between consumption and income? And if it has an influence, is this influence very high or very low? Is it a little influence and such? Now realize to answer that question, you therefore need to compare the correlation coefficient when actually we have the controlling variable, that is the controlling variable, and when we don't have the controlling variable, and when we have the controlling variable. Now realize for this case, when we have a controlling variable, let's start with this first case, the correlation value is significant. It is positive, and again, it is positive, strong, and it is significant. Again, when we don't have the network, or rather the controlling variable, we realize that the correlation coefficient is again positive and strong positive, and most importantly, it's still significant. So this implies that even though network as a controlling variable has an influence on the association, or rather the correlation of consumption and income, the fact remains to be network have a very little effect or influence on the association of consumption and income. And the reason why I'm saying it is a very little influence in controlling the relationship of consumption and income is that even though we don't have it as a controlling here, but the correlation coefficient is still significant. So it has a very little influence, because if this influence was very high, realize either of the two, one could be insignificant and the other one is significant. That is now the case when we say it has a very high influence, or maybe it was high, positive, strong, now it is now weak and such. But in both cases, it's strong and it's significant. And because of the fact that in both cases, whether we are having network as a control or we don't have, still the association between consumption and income is significant. Therefore, we conclude that network has a very little influence on the relationship between consumption and income. That is the final deduction that we say. Guys, is that clear? Is that message at home? So I think now we can do another one and have some members interpret that. Let me just do another. Let's just do another one. Correlate. Partial correlation. Maybe now this time round we are looking at. Okay, let's do consumption and income, and also have interest rate as a control. So let's have that. Now here we have consumption and income without a control variable. Now we have interest rate as a control variable. Can someone tell this, as Mr. Morrison always says? Someone to say something about this.
Okay, I'll try.
Okay.
Okay, from the partial correlation matrix, Pearson correlation coefficient is 0.788, implying that there is a strong positive correlation between consumption and income and is controlling interest rate. The significant is 0.00, which is less than 0.05, implying that the correlation between consumption and income, or at least interest rate, is significant.
While controlling for interest rate is significant. That is awesome. That is awesome. That is fantastic. That is fantastic. So someone to tell us if actually interest rate has high influence or a low influence on the correlation of consumption and income. Is the influence very high or little, or just a general? Someone to say about that.
Okay, let me try. I think interest rate has a very low significance because if you look at the correlation coefficient, both of them are positive, and the significance level, both of them are significant. Yeah.
That is marvelous. It's fantastic. It has a very little influence on the correlation of consumption and income. And like Madam Evelyn is saying, the significance in both cases actually is less than 5%, meaning that in both cases it is significant. So, and again, it's positive, and again, strong positive in both cases. So, if there is influence, then it is a very little influence on controlling for consumption and income. That is very nice. That is very nice, and I can tell that girls are dominating this class, while boys are busy listening to the lyrics. This is now lyrics. So that is correlation. That is correlation analysis, and I hope you always remember that. So basically, whenever this is now in conclusion, or rather general, whenever you are interpreting or rather storytelling, we say data storytelling for correlation, you need to take into consideration three important aspects. Number one, the direction of the correlation coefficient. Is it positive? Is it negative? That is what I mean by direction. Number two, the strength of the correlation coefficient. Is the correlation coefficient strong, weak? That is now I'm talking about the strength. And most importantly, also number three, equally important, is the significance. Is this correlation coefficient statistically significant? Taking care of those three, you're good to go. Taking care of those three, you're good to go. Now look here, we have actually been able to tell that there is an association between consumption and income. And at one point we are even saying, based on the scatter plot and the correlation value, we are even saying that we are expecting that as income increases, the consumption also increases. Now someone will be interested to know, as suppose income is measured in shillings, 1 shilling, as now this income increases by 1 shilling, what or for how many units is consumption increasing? You see, we have those questions. Again, suppose assuming is a guy working, and now the income is increased by, let's say, 100,000. What will be his consumption? What will be his consumption? Suppose the income is increased by 100,000. Now you see that brings the aspect of prediction. We want to predict the consumption given that this income has increased, because you are actually saying there is an increment. It is a positive. So you are expecting as it increases, the income increases, also consumption increases. This other case here, where we are having a negative correlation, the other case here we are having a negative correlation for family and consumption, so that we are saying as the family increases, the consumption increases. Maybe this is now consumption for those goods that are not necessary for the family. So as the family is increasing, you need maybe to stop spending on some commodities. Now those commodities that are not essential for the family. So suppose now the size of the family increases by 2. What will the consumption increase to? So there's that essence of doing the prediction. We want to do a prediction by getting an actual value. So we realize correlation analysis does not give us that room to do the prediction. It is just telling us that there is actually a relationship, and tell us if that relationship is positive or negative, and as well as tell us the significance of that relationship. But it doesn't give us a room to predict, to do a prediction, so that we can prepare ourselves for the future. Now, in order to do prediction, we realize that we need to do another type of inferential analysis. And for this case, the very fundamental and famous is regression analysis. Where now we are trying to get the relationship between these two variables so that we can do a prediction. We are trying to see what happens to consumption when family changes or when income changes. And at the end of the day, do prediction for consumption when these other factors are changing. That is now regression analysis, the famous regression that we all know. Now, the regression analysis is also having underlying assumption. One of them is the linear relationship. So of course we have to do the linear relationship and all that. Now, because in this class I want us to do almost all aspects of regression, I will not start regression today. We will not do regression today, but I'll just give a hint of what we will do. I mean, in one of the blogs that I was creating, I wrote about the nature of the dataset and the type of the regression analysis. Now, that blog will play a very key role in our analysis as far as regression is concerned. So if you've never read about that, kindly just go and read and understand. Because you realize there are various types of regression analysis here. You can see we have automatic linear model, we have linear model, curve estimation, partial least square, binary logistic regression, multinomial logistic regression, ordinal, probability, nonlinear, and all that. So in this SPSS class, we will focus on the linear regression, the binary logistic regression, multinomial logistic, ordinal, and the famous probability analysis regression as well. So the question is, when are we doing this type of regression analysis and not the other one? When do we do linear? When do we do binary logistic? When do we do multinomial logistic? And when do we do ordinal logistic? I'll just finish by just explaining that as we wind up with our 8 minutes, so that next time we just do the regression itself. And this is very important because people rush to do the analysis without considering what is actually required for that particular type of analysis. Now, linear regression analysis is based on assumption, and the assumption number 1 is linear relationship. There is a relationship between the dependent variable and the independent variable. Remember when we were discussing advanced Excel, we defined what a dependent variable is and what a independent variable is. And we say dependent variable is one which is being influenced by another variable, and that variable which influences the dependent variable is what is called the independent variable. So one assumption is that we assume there is a linear relationship between the two, and you can see we are actually confirming the presence of linear relationship using the scatter plot. That is one of the best way to confirm that. So that assumption already holds. That is one. And in most of the cases, for me, before I even confirm the linear relationship, one thing is that are these data sets continuous? Because in most of the cases, the linear relationship will only be possible for the case of continuous variable. So when such that the dependent variable, the one we are trying to estimate the effect as a result of the independent, is continuous, then I'll consider linear regression. Now realize when now the dependent variable is categorical, I'll come to either of these three options. That is the binary logistic, multinomial logistic, and ordinal logistic. These three again. So I want us to finish by discussing when we use this. Now, the dependent variable is categorical in this case. Realize it can be categorical with only two categories. That is, it is categorical with two levels. The rule is that we define what a categorical variable is. So it is categorical with only two categories. A good example is heart disease. As a variable, you either have the heart disease or not. So it's binary, 0 or 1. You have the disease or you don't have. So there are those factors that could lead to a heart disease. Maybe sugar level, maybe cholesterol level, maybe the heartbeat, blood sugar, using all those factors. So we want to see if those factors significantly affect the possibility of you having heart disease. The dependent variable is binary, 0 or 1. Now we use binary logistic regression. The dependent variable is categorical. Remember, we are determining this type here, we are not talking about the independent. We are talking about the dependent. So it is categorical in 2, it is binary, 0 or 1. Now, multinomial and ordinal. Now, this is a case whereby we have a categorical dependent variable with more than 2 categories, number 1. Now, that is the case of multinomial and ordinal. They have more than 2 categories, because if they were only 2, we will go for binary. But now they are more than 2. So the question is, from these 2, can we order them or not? Now, let's take an example of student performance, measured in terms of maybe excellent, very good, poor, very poor. We realize in such a case, we have 5 categories which actually can be ordered. I see that. So maybe we are looking at the edge affecting the performance of the student. Around the performance of the student is measured as very excellent, very good, poor, very poor. Now we have age of the student, maybe the income of the student. Could be mwanafunzi anainama sana, so there is no good performance. So the income of the student and we will go for ordinal, because the dependent categorical variable can be ordered. From the word order, we are using ordinal. That is that. Now the last instance is now for multinomial logistic. Now for multinomial logistic is a case whereby this categorical dependent variable, number 1, has more than 2 levels, because if there were two, we could go for binary. But now these categories can never be ordered, cannot be ordered. That is multinomial logistic. A good example of the dependent variable here is color. Suppose you want to see color is being affected by maybe on manufacturing clothes. So the color red, black, white, maybe is affected by the amount of money I have, or maybe the number of customers and all that. So now my color, I'll maybe have black, blue, red, yellow, orange as the colors. So the categorical variable color is the dependent variable with 5 categories, but they cannot be ordered. So there are more than 2, but they cannot be ordered. I'll go for multinomial logistic regression. I'll go for multinomial logistic regression. Sense?
Yes.
Perfect. Now, what I'm going to say now, I don't want to confuse you, but that is what we'll be focusing on in our next class. We are going to focus on regression analysis and specifically linear regression analysis. Because now we have determined that our dependent variable is continuous and there is a linear relationship between the dependent variable and the independent variable. So we are going for linear. Again, we realize the linear regression, we can have like 3 models that we can discuss about. Number 1, simple linear regression analysis. 2, multiple linear regression analysis. And 3, linear regression with dummy variables. Now we realize when we were determining the type of regression generally that to be linear or what, we are looking at the dependent variable. Now for this case, now we have chosen our model is linear. For this we have just mentioned, we are now looking at the nature of the independent variable. 1. If we have only one independent variable, suppose we want to investigate if income, I'm using the example we have in the data set, income as dependent being affected by, consumption being affected by income, consumption being affected by income. There is now a simple linear regression analysis. Only one independent variable. Now, the second type is multiple linear regression. There is a case where now we have more than one independent variable. For example, I want to investigate the relationship of consumption and income and the size of the family. Now you see I have 2 independent variables and 1 dependent. So it is a multiple regression analysis. Now the last one, that is regression analysis, linear regression analysis with dummy variables, is a case whereby one of those dependent variables, be it in simple or in multiple case, but one of those dependent variables is a categorical variable, such that maybe I'm investigating the effect of consumption, the relationship of consumption as a result of income and gender. So you see in this case, gender is a categorical variable as it is an independent categorical variable. So you realize the way we'll be interpreting that will be different with the way we'll be interpreting continuous variable. So in our next class tomorrow, inshallah, we will be focusing on linear regression model and we'll be discussing the 3 instances. So you can take your time, go and read, and maybe we will have the class as more. Otherwise, unless you have questions, there is our class today. Our focus was on correlation analysis. Okay, if there is no question, I'm still waiting for your assignment. I'm happy for those who have shared the assignment over the weekend. Tomorrow I'll be giving a feedback to them. I wish you a good night and may you wake up and a good night. Bye.